This micro-credential deals with troubleshooting methods and consists of 5 targeted skills. This targeted skill deals with OSI model basics. Models are a way that can take something that is complex and make it more understandable. For example, most people are familiar with what an atom looks like. However, no one has really ever seen one. Atoms are much too small for even the most powerful microscopes. Therefore, a model of what people think they look like helps them to understand how they may function. Do they really look like that? Maybe, but what they look like is not as important as how they work. A conceptual model helps with that. The Open Systems Interconnection OSI model is similar to the model of an atom. The International Organization for Standardization developed it to help people understand how 2 devices on a network communicate. The process is divided into 7 layers, with each of the layers having specific functions. Layer 7, the application layer, is closest to the user. Applications such as Microsoft Word or Google Chrome can actually work independently of the OSI model. However, when an application asks for a network service, such as when an essay written in Word is printed on a network printer, the application layer comes into play. Layer 6, the presentation layer, is the translator of the OSI model. The sending device uses this layer to ensure that the data that is being sent can be read at the application layer of the receiving device. Layer 5, the session layer, is responsible for establishing, maintaining, and terminating connections between 2 devices on the network. The sending device finds its communication partner and establishes a virtual connection with it. Think of this like making a phone call. It is started by dialing the number, and a connection is established when the other party answers and greetings are exchanged. During the conversation, the communication partners are exchanging information and maintaining the connection. When all the pertinent information has been exchanged, goodbyes are said and the conversation is terminated. Layer 4, the transport layer, is responsible for error correction and flow control. The data from the top 3 layers of the OSI model is broken down into smaller chunks called segments so it can be transmitted across the network. Sequence and acknowledgement numbers are used for correct reassembly and keeping track of missing segments for error correction. The transmitting computer creates a sliding window determining the number of segments that can be transmitted before requiring acknowledgement. This window is based on the speed and reliability of intervening network connections. Finally, the transport layer adds port numbers to keep track of which application layer protocol the data is intended for. Layer 3, the network layer, is responsible for encapsulating each segment into a packet and adding the source and destination Internet Protocol IP address. Every device needs an IP address to transmit data beyond the local area network, or LAN, to which it belongs. These addresses are considered logical addresses because they are programmed into the device. Each of these addresses are unique to each device and supply information about which network a host device belongs to, allowing the packet to be routed across networks to reach its destination. Layer 2 is the data link layer. At this layer, the information receives its final formatting by encapsulating the network layer packet into a frame. The frame includes the media access control address, the MAC address, of both the source and the destination devices. MAC addresses are used by devices to communicate on the local area network. Both the source and destination MACs and IPs are necessary for any data to be transmitted across the computer network. MAC addresses are also called hardware or physical addresses and are burned into the read-only memory, ROM, on the network interface card, the NIC. The data link layer is also responsible for error detection. This is accomplished by adding a frame check sequence, an FCS, to each of the frames. The FCS is a numeric value calculated from the original size of the frame. If a different value is calculated on a receiving computer, it is assumed that it had been altered or damaged in transmission and will be discarded. The transport layer will then ask for the missing segment to be retransmitted. Layer 1 is known as the physical layer and is the bottom layer of the OSI model. The physical layer does not perform any processing of the data and only sees it as bits. The physical layer is responsible for encoding these bits into a form that can be transmitted across the network media, such as electronic signals, pulses of light, radio waves, etc. Data flow in the OSI model begins with an application's request for network services starting at layer 7 of the OSI model, and is then modified by each layer as it flows down to layer 1 for transmission across the media. Connectivity devices like switches and routers are used to help the data to get to the destination and process the data according to their function. For example, switches use MAC addresses to make decisions, so they function at layer 2 of the OSI model. When the data arrives at the destination, the process is reversed and the data checked and reassembles as it flows back up the OSI model to its intended application. Finally, remember that the Open System Interconnection OSI model was developed to help people understand how two devices on a network communicate.